Hello, in this video we will look into the second exam practice question for GCSE topic thermistor. If you want to revise thermistors, please do refer to my previous video on this topic. The question that we've selected for this video is about a graph, and you would be asked to analyze this graph. So at GCSE level, this is quite a common practice where a graph is given. So whenever you're faced with such a question, start with the simplest thing, read the question. So a computer is set up to produce a graph. So we've got the graph here of the current. So we've got current through an electric lamp. So we've got the lamp there. During the first millisecond, so notice the unit of time. We know that the time needs to be in seconds, so we would need to remember to convert it if needed. So just keep that in mind after it is switched on. So we've got time here, we've got current on the y-axis. Now the lamp is modified and then tested in the same way. So they haven't mentioned much about what they've done to the lamp, but they've suggested that the lamp has changed, and because of that, the graph has changed. Now, based on the graph, you will be able to figure out that actually this particular graph gave us more current at the start. Now, once the lamp has been modified, at time 0, you've got 0 current. So what they're asking you to find is describe 3 differences in the way the lamp behaves after it has been modified. So these are quite bonus questions, really. You don't need any application of concept. You don't need to use any of your understanding about the topic, but actually you can look at the graph and decode it. So when you look at the graph here, you can say that in this particular second graph, current starts from 0. So we can see that. So current starts from 0. So that's a change. You can say that the current produced is only less than 0.5. So 0.5 amp is the change in current, right? So it's a change in current. So it changed from 0 to 0.45. You can see that the current produced is quicker. So it takes about 2 milliseconds for current to settle. So you don't have to wait for longer, whereas in the previous graph, you can see you had to wait till 4 milliseconds for the current to settle down. Whereas here you get the same amount of current, but very quickly you get that. Now the maximum current in the second graph is 0.45 amps, whereas in the first one, you've got the maximum current is 1.5 amps. So in this particular analysis, all you have to do is you've got to compare the graph and you just say, how is it different after the graph, after the lamp has been modified? So you could pick up any of these points. As long as you are comparing the graphs, you will be fine. So that's a bonus question. So whenever graphical analysis is there, decode every part of the graph. Now we've got another graphical analysis here. Now the current through the modified lamp depends on the total resistance of the filament and the component X. So they've added something to the lamp that indicates that now the resistance, the current through the lamp depends on a filament as well as component X. The smaller this total resistance, greater the current. So we've got that information already provided for us. The following graphs show how the resistance of the filament lamp, so that's your filament lamp, and the component X, so that is component X. So we've got a bit of data here and we need to understand it. So that's the data for lamp, and that's the graph for component X. And they're showing as the lamp heats up. So they're plotting the graph with resistance versus temperature. So now you have to, sorry, I've gone ahead. So you got to use the information shown on the graph to explain the behavior of the modified lamp. you've got to use the information of the graph. So it's plural, so you've got to use both. So you would say in the lamp. So you could start with decoding information. So for the lamp, you would say R increases as temperature rises. So that's the relationship there. R of X, whereas in this one you would say R of X falls as temperature increases. So total R will stay roughly the same as T increases. So overall the current would roughly stay the same. R of X falls faster. As you can see, the drop is faster drop. So there is a faster drop here at first, then R of the lamp. So so the current will increase. R of X is high at the start, so current is 0 or low at the start. So all you need to do is decode the graph and just explain what the graph is talking about. So these type of questions are your bonus questions, whereby you just look at the graph and you talk about what each graph tells you. So you're literally talking about if a graph has got quite a sharp drop, you could say what's happening at the start. So in this case, you talk about what was the value there, what happens towards the end, and what sort of gradient you've got here. So you would say that that's quite a sharp drop, and then it gradually plateaus out. So its quiet resistance is very high. So initially you will have, if the resistance is high, current is very low. So that's how you do graphical analysis. And these questions would be for 3 marks each. So the previous one and this one would be 3 marks. So this is the discussion about the second question. In the third video, I will be looking into the third question, which involves some calculations of thermistors and resistance. So I'll see you at the third video. Thank you for watching.